Welcome to Bedtime Astronomy. Explore the wonders of the cosmos with our soothing Bedtime Astronomy podcast. Each episode offers a gentle journey through the stars, planets, and beyond, perfect for unwinding after a long day. Let's travel through the mysteries of the universe as you drift off into a peaceful slumber under the night sky. The Focault Pendulum. The Focault Pendulum, a simple yet profoundly illustrative device, is an emblem of Earth's rotation and a crucial instrument in the realm of astronomy. Conceived in the mid-19th century by French physicist Léon Foucault, it demonstrates the rotation of the Earth in a manner that is both comprehensible and awe-inspiring. To understand its significance, we must explore its history, design, and the profound implications it holds for our understanding of the universe. Before the invention of the Focault pendulum, proving Earth's rotation was a challenge. Although Copernicus had postulated a heliocentric model of the solar system in the 16th century, direct, observable evidence of Earth's rotation remained elusive. While astronomers like Galileo and Kepler laid the groundwork for modern astronomy, it was not until the 19th century that a simple and direct demonstration of Earth's rotation became possible. In 1851, Léon Foucault, a self-taught physicist and son of a Parisian bookseller, presented an elegant solution. By suspending a heavy pendulum and allowing it to swing freely, Foucault demonstrated that the plane of its swing appeared to rotate over time. This effect was due to the rotation of the Earth beneath the pendulum. Foucault's pendulum provided the first simple and direct visual evidence of Earth's rotation, captivating scientists and the general public alike. A Focault pendulum consists of a long wire and a heavy bob suspended from a fixed point. The bob is set into motion, swinging back and forth in a plane. Ideally, there should be minimal air resistance and friction at the pivot point to ensure that the pendulum swings for a long period. The key observation is that the plane of the pendulum's swing appears to rotate over time, relative to the surface of the Earth. The rate of this rotation depends on the latitude of the pendulum's location. At the poles, the plane of the pendulum's swing completes a full rotation in 24 hours. At the equator, there is no observed rotation. At intermediate latitudes, the rotation rate varies, providing a direct correlation between the pendulum's behavior and the Earth's rotation. The Focault pendulum holds profound implications for astronomy and our understanding of Earth's place in the cosmos. By providing tangible evidence of Earth's rotation, it corroborated the heliocentric model of the solar system. It also reinforced the understanding that Earth is not a static body, but one in constant motion, rotating on its axis and orbiting the Sun. The Focault pendulum also illustrates the Coriolis effect, which is the apparent deflection of moving objects when viewed from a rotating reference frame. This effect is crucial in meteorology and oceanography, influencing weather patterns and ocean currents. In astronomy, the Coriolis effect is relevant when considering the rotation of celestial bodies and the dynamics of planetary atmospheres. The behavior of the Focault pendulum is akin to gyroscopic precession, where a spinning object, like a gyroscope, maintains its orientation unless acted upon by an external torque. This principle is applied in the stabilization of telescopes and spacecraft, ensuring they maintain a fixed orientation in space despite the rotation of the Earth or other perturbations. Today, Focault pendulums are installed in museums, universities, and observatories worldwide, serving both as educational tools and as reminders of the interconnectedness of physics and astronomy. They exemplify the principles of classical mechanics and provide a tangible link to the broader concepts of celestial mechanics. Focault pendulums play a significant role in public outreach and education. By observing a pendulum in motion, people can witness the Earth's rotation in real time, fostering a greater appreciation for the dynamic nature of our planet. Many institutions incorporate Focault pendulums into their exhibits to illustrate fundamental principles of physics and astronomy. In addition to their educational value, Focault pendulums have been used in research to study the effects of Earth's rotation on various physical phenomena. They have provided insights into seismic activity, tidal forces, and even relativistic effects predicted by Einstein's theory of general relativity. The precision and simplicity of the pendulum make it a valuable tool for experimental physics and astronomy. While the Focault pendulum primarily demonstrates classical mechanics, it also has implications for the theory of relativity. The rotation of the pendulum's plane of oscillation can be influenced by relativistic effects, such as frame dragging, where the rotation of a massive body, like Earth, drags the spacetime around it. This subtle effect, predicted by Einstein's theory, has been studied using highly precise versions of the Focault pendulum and other gyroscopic experiments. The Focault pendulum stands as a symbol of scientific inquiry and the quest for understanding our universe. Its elegant simplicity belies the profound truths it reveals about the nature of our planet and its motion through space. It embodies the spirit of curiosity and discovery that drives astronomers and physicists to explore the cosmos. The Focault pendulum is more than just a demonstration of Earth's rotation. It is a powerful tool that bridges the gap between classical mechanics and modern astronomy. By providing direct evidence of Earth's motion, it has deepened our understanding of the dynamics of our planet and its place in the universe. Its continued use in education, research, and public outreach ensures that the legacy of Leon Foucault's simple yet revolutionary invention will endure, inspiring future generations to explore the wonders of the cosmos. The Focault pendulum, swinging silently in museums and observatories, continues to remind us of the Earth's perpetual dance in the vast expanse of space. As it traces its path, it tells the story of our journey from a geocentric view to a dynamic, heliocentric understanding of our world. Its enduring presence serves as a testament to the power of scientific inquiry and the unceasing human desire to comprehend the universe in which we reside.